Okay, so today we're going to continue the discussion on the need analysis in terms of the system life cycle. And as I mentioned already, we are going to talk about two tools that are relevant in terms of helping you defining all the things that we discussed in terms of the needs analysis. We remember we talked about how to specify the objectives of your project and how from there you can split those objectives until you get no further split in terms of quantifying those objectives. And when you go further down, at the point that you should stop is when you start defining those functions. Then you use those functions to start defining your requirements in terms of your project. Again, requirements, we have discussed 6 different type of requirements already, and that's what I'm expecting you to list as part of your progress report. I want you to go and define the requirements for your project using the template that we discussed in class. So using those words that we discussed in class. And if you still have doubts about that, you can go online into the track side, and I have listed the lectures that are referring to requirements in the video list. And from there, today we're going to look at these tools, these 2 tools that are helpful in terms of helping you with that process of the system lifecycle process. So Causal-Loop models or influencing models and N-squared charts. So we're going to start with the Causal-Loop, and the idea with these Causal-Loop models is that you can start seeing some of the connections between the inputs and the behavior of your system. Okay, so Causal-Loop diagrams are a useful way to represent dynamic interrelationships. They provide a visual representation with which to communicate that understanding. So most of your systems are complex, and we define that at the beginning of this semester. They have multiple inputs. They have complex behavior in terms of the interactions, changing states within it. And then based on that, you're going to have some generation of outputs. These Causal-Loop diagrams allow you to provide a visual representation of the behavior of your system. So what are the components of your Causal-Loop models? You have variables, which is an element in a situation which might act or be acted upon. They vary up and down or down over time. This is not an event. And you can use nouns or noun phrases to describe them. And we also have links and arrows. So they show the relationship and the direction of influence between the variables. So the idea is you define these variables, and then you're going to start connecting them in terms of how this variable is impacting the next variable. If it's going to increase or somehow have an impact, positive impact onto the next variable, then that's going to be shown in this list. The same way, if it has a negative impact, we're going to show that in our arrows. So there are many ways to look at the world. Okay, Causal-Loop models allow for modeling nonlinear systems using cause and effect. So that's the idea. We see how this is going to somehow impact the next variable. So we want to see, okay, so if this is the cause, what will be the impact on or the effect on these other areas of my system? Some of the viewpoints of the Causal-Loop models include disjoint, linear, control, and Causal-Loop nonlinear feedback, which is the focus of this lecture. Sign diagrams showing rates and level of prevalent factors represent the flow of the casualty. Apologize. So always take your notation when constructing Causal-Loop models. What that means is you're going to be building these diagrams. I need to understand what the arrows are meaning for you in terms of being the modeler. So if your arrows with the plus sign represent a positive effect, you have to list that as part of your notation. If your arrows with a red color represent a positive event, then you have to let me know that as part of your notation. So, these three viewpoints are illustrated here: the disjoint linear control and causal loop nonlinear feedback. They're illustrated here, as you can see. In the disjoint point of view or viewpoint, there's no connection between these three. They are independent. When you look at the linear control, the effect is serial. So you go from one point to the other, and then this one impact this one, and this one impact it once. When you look at the causal loop nonlinear feedback, even though you have a loop here, that not necessarily is what is going to happen every time. You might also have an effect going in this direction, connecting this point to this point as well. So the disjoint viewpoint of discrete cause and effect is the antithesis of system thinking. The disjoint viewpoint looks for a singular solution or a silver bullet. So we want to identify something and then blame everything to that specific item. And that's contrary to what we have learned so far in terms of system thinking and systems engineering. Many engineers, planners, project managers take a linear control viewpoint of cause and effect. So everything is linked through the beginning or the origin. String activities into sequences. The output or the effect of one becomes the input or the cause of the next event. For example, if you are familiar with this type of chart, the Gantt charts and the PERT charts, those are linear type of diagrams in which you see the connection from the beginning to the end, but there's no connection among that first event and maybe some of the last events. The linear control viewpoint is dominant. It is deeply flawed since it does not take into account reaction. So everything is going to follow this line and nothing happens. There's no feedback happening in those diagrams. Stimulating any system causes a reaction which opposes the stimulus. Reaction is the heart of science and engineering, yet it is often overlooked when developing plans. So we want to set up these plans following this linear approach, this series approach. We don't allow for reaction, and that's what we are trying to account for in these diagrams that you're going to learn today. Continuing triumph of hope over experience. The causal loop nonlinear feedback viewpoint comes close to the real world. So we are trying to avoid the use of those linear or sequence diagrams. We want to see how can we model the interaction among these variables and the feedback. So it's not just going in one direction. Cause results in effect, which feeds back sometimes through other systems who interact with the cause. A causal loop is generally either negative or positive in the sense that feedback or the effect either counters or reinforces the initiating cause. So this is a very simple example here. So if you have seen this before, you know that there's going to be a reaction. If you move the first ball of that, it's going to somehow transfer the force. You will not see this moving, but the last one is going to move and is going to react to that cause. So let's look at one example, what I'm trying to illustrate with these diagrams. So there's two examples here, or two scenarios. One of them is used in population dynamics. So the idea is we're going to list some variables here, and we're going to try to connect the interaction from these variables. So I'm going to keep this scenario simple. I'm going to list only 3 variables, even though we know that they can be more. So let's see, we're going to have, in terms of population dynamics, we can have 3 variables. And this is not working. So we're going to, on the other side, we can list the deaths, and we're going to see how those impact the population. Okay, so we have the population, we have 2 variables, births and deaths. So as I mentioned, we want to define our notation. So in this case, I'm going to use these 2 arrows. Okay, so they have different colors. So the white arrow would denote a positive or reinforced effect, and the dark arrow will be a negative or contrary effect. So if we think about birth, right, that will have a reinforced effect or positive effect. The more birth you have, more likely you're going to have an increase in your population, right? The more population you have, most likely you're going to have an increase on your deaths. The more citizens, more likely those numbers are going to be higher, because the more citizens you have, the higher chances of getting more people to die. However, this variable has a contrary or negative effect on your population. More deaths you have, more likely you're going to have a descent on your numbers in terms of population. And then going back here, the more population you have, the more births you will expect. So as you can see, we are trying to link cause and effects events here to these 2 variables in terms of population. Right? We have deaths and births, and these causal loop models help us to visualize how these 2 variables are impacting your population. On the next example, this one is, so this is the notation, right? Remember, I'm stating my notation. So hollow arrowhead denote reinforcement, solid arrowheads denotes a contrary or opposing effect. So the dynamics of resistance to innovation. This is more in terms of, if you work for a company, you go there as a new engineer, most likely you're going to have all these new training experiences. You're going to be familiar with new technology. So most of the time when you go there as a new engineer, you come with all these ideas, and you're going to face this problem from the people that are being there for 20, 25 years in the company. Not all of them, but some of them will kind of resist those new ideas because they are in their comfort situation right now. Everything is moving smoothly. So when you go there with these new ideas, this probably will be the case. You're going to have this resistance to your innovation. So here I'm going to put again innovation in the middle, and I'm going to list some of the variables, okay, that can influence this. We can say change, resettlement, reaction. What is the reaction? Maybe opposition. Sales. How is innovation affecting your sales? How is that affecting your profit? How is that affecting your research and your new ideas? So keep in mind that most of these large companies like Google, Facebook, car industry, General Motors, Hyundai, Honda, any company that you think about that are large in a sense, and they face, and these companies that face a lot of competition, they will have a big department called research and innovation. Okay, so the idea with that is they want to keep developing new tools, new ideas, new products, so they can be competitive and also get the market. That's the idea. So if I come with a new vehicle, I can sell more if the people accept that vehicle. If I come with a new tool in Google and the people accept that tool, I'm probably going to get more revenue because of sales, in terms of ads, and so on. So you will see that. So the idea is that you continue that innovation. So we can see the innovation from two viewpoints in the same diagram. One in terms of the people that are resenting the change, but one in terms of how the innovation is affecting the company. So if I were to link this, innovation has a positive impact in terms of change. Most of the time you're trying to come up with something new that's going to end up providing some change in terms of what you're trying to do and how things are being done. However, that change, more likely, since we are talking to dynamics of resistance to innovation, will also reinforce that feeling of resentment for some of the people that are against new things, which is going to also most likely create a reaction, which is also going to have a reinforcement in terms of opposition. So why are we putting the money there? We have a safe business. We have sales that are steady. We are moving in the right direction. Why do we change things? Why if it goes wrong? If it goes wrong, we're going to be losing this much money. We're going to be losing all this market. Our clients are going to complain. So all those things you're going to hear for sure. And then opposition basically has a negative impact to innovation. So an opposing effect to this innovation. Now if I go to the other side, you know that innovation most likely, if it is successful, is going to drive your sales up. If you come with a new idea in terms of cell phones, if you come with a new idea in terms of screen design, if you come with a new idea in terms of manufacturing certain products or manufacturing certain materials, if you are the leader, if you are leading the innovation in that side, most likely that's going to represent some new sales and some extra profit. And that profit also, that extra profit, most of the time what companies are going to do with that profit, obviously they're going to share that with some of that with the stakeholders, but some of it is going to go to research so they can continue their innovation. So this has some positive effect, and that research is going to end up in new ideas, which are going to also continue that innovation as part of the company. So you can see how this works. We are trying to list all these variables for this specific situation and trying to connect how all of them are affecting that specific area of the problem. So most of the time these tools are used as a brainstorm tool within the company. So you have, let's say, people are trying to realize that there are things that can be done in a better way. So you are going to come up with a board, and you're going to start, okay, so let's talk about it, let's brainstorm. So this is the situation. What are the things, what are the parts of the business that are going to be impacted by this problem? Can we link all of them? Can we link all the reactions, and then you have a better understanding of your problem. So if you go look at this, you say, okay, or maybe the first one, which is more simple. So let's say that we are seeing a decline in the population, and as many countries are seeing right now. So how can we link all the variables related to that situation? This is a good tool that you can use. You can list all the variables, and you can see, okay, these are the things, these are how are they connected. And then based on that, you can start seeing, okay, so what are the things, what are the interventions that we can do in order to help improve that specific problem, if possible. So I don't know if you're familiar with Dilbert, but this is one comic that I found that is related to causal loops. So our goal is to write bug-free software. I'll pay the $10 bonus for every bug you find and fix. So that's the situation. As you can see, all the engineers went happy because they can get rich by doing that. So I hope this drives the right behavior. Not likely, they're going to try to find more bugs in order to make more money. So that's basically seeing that not necessarily the interventions that you're proposing are going to have the effect. You can, if you list all the possible variables, then you can phrase this in a way that will not necessarily cause this. So Causal-Loop model shows how the overall combination of systems behaves, while at the same time ignoring the organization structure of the company. Causal-Loop model suggests how the issue of opposition to innovation might be tackled. So for example, if we look back at that diagram, reducing the effect of the right antagonist loop will allow for innovation to flourish. So if we look at this opposition, how can we manage that opposition? Can we phrase the innovation in a different way? Can we make them part of the change? And so on. So if we can target this, then we can change this to a different type of arrow or a positive arrow, and that will allow innovation to flourish. Involve the organization in the innovation process. That's what I was just mentioning. So that might help in terms of changing that point of view of opposition. Here are more examples. This is a Causal-Loop model for body temperature regulation. So if you're familiar with the signs of that, this Causal-Loop model shows all the variables that are related in that process. And then this is another one. And as you can see, these models are also used not only in engineering, but these are social science problems. This is the kill inhibition in humans. So this is a major problem that is being exposed lately with video games and TV. So how people are getting more familiar of seeing violence. And this is what this Causal-Loop model is trying to represent. So how can we change that? We can look at all the variables that are having a positive or negative reinforcement and try to focus on those. So a Causal-Loop model expresses openly and very clearly the thoughts and idea of its originator. enables dialogue, as I was mentioned, brainstorming tool, a very good tool for brainstorming, allows for correction and further development. So if you state your Causal-Loop model and you start discussing that with your peers, most likely you're going to be revising according to the input that you're receiving. It's useful for representing the behavior, nonlinear dynamical systems, and promotes and ensures completeness. So through the discussion, you will talk to your peers, you will try to make sure that it addresses all the possible variables that are part of the problem. Okay, so now I want you to work independently. I was thinking of doing it in a group, but I think it would be better for you to work on your own. So this is what we are going to do. You're going to be working by yourself. We're going to look at this problem, and we're going to try to come up with a Causal-Loop model for this specific situation. So if you're, I'm pretty sure that all of you are familiar with staying at a hotel at some point. So you can list good and bad factors about your hotel stay. And this is basically helping you to list the variables for your activity. And now use negative inversion to construct your Causal-Loop model. So you're going to create a list of negative factors that are likely to happen. So this is just to try to help you think about it. The only thing that you have to submit is the diagram that is in the paper. So you can think about good factors, bad factors, but at the end I want you to focus on that list of negative factors and deliberately consisting of pejorative adjectives and a noun, and put the various factors together and drop the pejorative terms. So for example, you can see low cost efficiency, so you can think about efficiency, dirty laundry, you can just list it as laundry, badly cooked food, and food, sloppy service, then service, and we're going to use these ones. And you're going to list some of them in this 1, 2, and 3, and then you're going to start linking them with these variables that are here, as we did for the examples. So now using the information below and 3 of your comments from this list, you're going to list those here, 1, 2, and 3. Connect the factors in your Causal-Loop model as indicated by the dotted lines. So in your case, I have given you the dotted lines. So those lines on the Causal-Loop model assumes the business reinforces cost efficiency, which is the extent to which hotel resources are converted into improved service quality and customer satisfaction at a minimal cost. So what I want you to do again, you're going to come up with this list, your own list. You're going to choose 3 and you're going to put them here. One of them, these 2 are already there, food and laundry, so they have to be different. For instance, if you're talking about low cost efficiency, you can use efficiency and put efficiency here. And then once you have put those 3 in here, you're going to use the dotted lines to see if those items are reinforcing or having a positive effect in service quality, for instance, or customer satisfaction, and how all of them connected in a positive or negative capacity. Does that make sense? Okay, so I'm going to let you work on that.